In this video, we're going to talk about two more indeterminate forms, the indeterminate product and indeterminate difference. Okay, so that's 0 times positive or negative infinity and positive infinity minus positive infinity. Okay, why are these two considered to be indeterminate forms? Uh, Again, remember we are talking about limits. So the product between 0 and positive or negative infinity, it can be 0, it can be positive or negative infinity, it can be any other real number. Okay, again, because uh, limits are involved. Okay, the same way with positive infinity minus positive infinity. It can be another infinity, it can be any other real number, it can also be 0, depending on what's given. Okay, how about if we have positive infinity plus positive infinity? So that's basically infinity plus infinity. It's not an indeterminate, it's an undefined because we can immediately say that it's positive infinity, right? How about if we have negative infinity plus negative infinity? This is just negative infinity minus negative infinity, right? Again, this is not an indeterminate form because we can immediately conclude that this is just equal to negative infinity, right? Unlike positive infinity minus positive infinity, it can be any real number. It can be positive infinity, it can be negative infinity, it can be 0. Okay, so it's an indeterminate form, this one. Now let's discuss how to evaluate these types of indeterminate forms. Okay, remember that L'Hopital's rule can only be applied to 0 over 0 and infinity over infinity indeterminate forms. Okay, so for us to apply L'Hopital's rule for indeterminate products and indeterminate differences, we have to manipulate the expressions so as to transform them to these forms. Okay, for instance, we have 0 times positive or negative infinity. This is actually a product of two expressions or two functions, right? So for instance, f of x times g of x. So our goal here is to manipulate this product, this expression, so as to get either 0 over 0 or infinity over infinity. Okay, so to do that, we can either uh, retain f of x and then divide it by the reciprocal of g of x, or retain g of x and then divide it by the reciprocal of f of x. Okay, these two are uh, just equivalent to f of x times g of x. Okay, so for instance, if f of x is 0 and then g of x is positive or negative infinity, then we have here for the first option f of x is 0, right? And then g of x is infinity. So 1 divided by infinity, that's approaching 0. Okay, and then if, for example, if we use this one, g of x is infinity, positive or negative infinity, and then f of x is 0. So 1 divided by 0, that ratio will approach infinity. Okay, so we now have 0 over 0 or infinity over infinity. We can now apply the L'Hopital's rule. All right. Now for the difference, infinity minus infinity, we can actually uh, represent the two terms as two functions or two expressions, two separate expressions. Okay, f of x minus g of x. Uh, Again, our goal is to manipulate this expression so that we can transform it to either 0 over 0 or infinity over infinity. And in order to do that, we can apply some techniques, algebraic techniques like uh, taking the LCD, combining the two using LCD. Or if trigonometric functions are involved, then we can apply trigonometric identities and then again apply LCD, combine the two expressions using LCD, so on and so forth. Okay, you will either arrive at 0 over 0 or infinity over infinity, and then that's the time you apply L'Hopital's rule. Okay, so let's have some examples. First one, we are asked to find the limit of the product between x and cotangent of x as x approaches 0. Okay, so let's try to evaluate immediately as x approaches 0. Let's replace x with 0. So we have 0 times cotangent of 0. Remember that cotangent is the ratio between cosine and sine functions. Okay, so cotangent of 0, this is equivalent to cosine of 0, which is 1, right? And then divided by sine of 0, which is 0. Okay, this ratio will approach infinity, right? Therefore, overall, this results to 0 times infinity. It's an indeterminate product, all right? So uh, the next thing we need to do is to manipulate the given expression so that we can arrive at either 0 over 0 or infinity over infinity. Okay, so let's do that. Again, this is our given. Uh, we can retain x and then divide it by the reciprocal of cotangent of x, where the reciprocal of cotangent of x is tangent of x. So we can rewrite this as limit of x divided by tangent of x. Okay, or we can retain cotangent of x and then divide it by the reciprocal of x. So for this option, we can rewrite this as cotangent of x divided by 1 over x. Okay, for the first one, this is in the form what? X is 0, and then tangent of 0 is 0. So we have 0 divided by 0. Or, if you opt for this one, cotangent of 0 again is infinity. Then we have here the ratio between 1 and x, where x is 0. So this will approach infinity. 1 over 0 will approach infinity, right? So we have here infinity over infinity. So either of the two, we can apply the L'Hopital's rule. However, one option will lead to an easier or more convenient solution as opposed to the other. Okay, so let's try the first one. We have your limit of x over tangent of x as x approaches 0. Let's try this one first. L'Hopital's rule, differentiate the numerator and denominator separately. Okay, derivative of x with respect to x, that's 1. And then derivative of tangent of x with respect to x, that's secant squared of x. Okay, so let's try to evaluate at x equals 0. We have 1 divided by secant squared of 0, where secant of 0 is 1. And then 1 squared is 1, so 1 divided by 1, we get 1. All right, this is now actually our final answer. Okay, now let's try if the second option will lead us to an easier solution or will it lead to a more complicated solution. Okay, so let's try again L'Hopital's rule, this time for the second option. Derivative of cotangent of x with respect to x, that's negative cosecant squared of x, right? And then derivative of 1 over x with respect to x, it's negative 1 over x squared. So at this point, we can clearly see that the solution becomes more complicated, right? So we can continue by simplifying this one. We can rewrite this as a ratio between x squared and cosecant x squared. We can continue to apply L'Hopital's rule, but again, looking at the two options, the first option is more convenient. So let's follow the first option. Okay. Next problem. We have here find the limit of the quantity secant x minus tangent of x as x approaches pi over 2. Okay, so let's try direct substitution. We have here secant of pi over 2. minus tangent of pi over 2. We can uh, use identities so that we can easily identify the values. Secant is 1 over cosine, and then tangent is the ratio between sine and cosine, right? So we now have 1 divided by cosine of pi over 2. Cosine of pi over 2 is 0, okay? And then sine of pi over 2 is 1. Again, cosine pi over 2 is 0, so we have 1 over 0. That is infinity minus infinity. We have an indeterminate difference, right? So the next step is to manipulate the given so that we can obtain either 0 over 0 or infinity over infinity and then apply L'Hopital's rule. Okay, so again, this is the given, and then since trigo functions are involved, we can apply the identities. Again, secant is the reciprocal of cosine, and then tangent is the ratio between sine and cosine. And then from here, uh, we can combine the two terms using LCD. Okay, and the LCD is cosine. So we have now 1 minus sine x divided by cosine x. We now have a single fraction. So let's check if we apply x equals pi over 2. Let's see if this results to either 0 over 0 or infinity over infinity. Okay, so let's try to substitute. We have 1 minus sine of pi over 2, right? Divided by cosine of pi over 2. Okay, so 1 minus sine of pi over 2. Sine of pi over 2 is 1. 1 minus 1 is 0. And then cosine pi over 2 is 0. So we now have an indeterminate quotient. We are now allowed to apply the L'Hopital's rule. Okay, so let's differentiate the numerator and denominator separately. Derivative of 1 minus sine x divided by x. This will give us negative cosine of x. And then derivative of cosine x with respect to x, that's negative sine x. Let us now evaluate at x equals pi over 2. So cosine pi over 2 divided by sine pi over 2, where cosine pi over 2 is 0, and then sine pi over 2 is 1. So this will give us 0, and this is our final answer.